Hello, everyone. Someone said that I needed to start these with music, so guess what? There you go. Okay, so next lesson in our functions unit, functions and relations, operations with functions. We're looking at the quotient, and yeah, you might want to tilt your screen, tilt your head. Sorry, this one's a little bit whack. Anyways, we're going to look at the quotient of two functions in this lesson. So first of all, we'll do this little investigation. So we have two functions, f of x and g of x, defined for all real numbers. Okay, the graphs of the functions are shown on the grid. So we have the two graphs plotted, and they also have a table of values here handy for us. Okay, the points marked with dots have integer coordinates, so we don't have to guess if the dot looks slightly off. You assume it's at, like this one here would be at 3, 6. That's what it means by integer coordinates. Whole number, positive or negative. Okay, complete the table below, and it looks like they want us to fill in the y values for f of x for these corresponding x values, and then the y values for g of x from this graph here, the straight line, for these corresponding x values, and then they want us to divide the y values to get this column. Okay, so I'm going to do that, and you guys are going to pause the video, and you're going to do that as well, and then we'll check back and see if we have the same answer. Okay, let's compare our tables. Hopefully we have the same y values. Scan through, make sure we have the same f of x or y values, same g of x, and if not, pause your video and correct. Okay, and then to get f divided by g of x, the quotient of the two functions, we take the y values and divide them. 6 divided by 1 is 6. Now if you'll notice on the next point, you get 0 divided by 0. Now, you can confirm that with the calculator, but when you're trying to divide by 0, you'll get an error because you can't divide by 0. So we would write undefined for that, okay? And down here, 0 divided by -5, it's okay to divide 0 by a number other than 0. So that one is equal to 0. Okay, now first question they ask after we complete the table is explain why the domain of the function f divided by g of x is not x and n the real. So they're implying that there's a value of x that isn't possible. Well, this one here, where we ended up with a y value for f divided by g that was undefined, as a result, we can't have this x value either. Okay, so that would mean that x cannot equal 2 because f divided by g at 2 was undefined. Okay, in other words, we were dividing by 0. Okay, part C, sketch the graph of f divided by g of x showing the domain restriction by drawing an open circle on the graph. Okay, so just like the other two lessons, we are going to plot the x values and the y values for f divided by g of x. So I'm going to do that. You're going to pause the video now and you're going to do it as well. Okay, so here's my plot of the points, and we have to decide now whether we're going to draw a line through these points and the arrows on the ends of the line. It did say that they were defined for all real numbers. Now we have to deal with that one point that was undefined, and we don't really know what the y value was because it ended up being undefined. But if you look at the trend of this graph, the y value should logically have landed right here. So we're going to actually draw an open dot there, okay? And then just make sure you don't draw the line through the dot. We're going to go like that. Okay? And there we go. There's our graph. Open dot implies that that point at x equals 2, 5 does not exist. Okay, let's look at what else they're asking us to do. Okay, sketch the graph, done. The functions f and g above are f of x equals x squared plus x minus 6 and g of x equals x minus 2. Write and simplify an expression for the function f divided by g of x. So again, writing that in a little bit different notation, that would be the same as f of x divided by g of x. And that was shown in lesson 2 at the very top of the page, what each of those are can be rewritten as. Okay, so let's put our given functions in for each of those. Okay, so write, done, and simplify the expression for the function, including the domain restriction. Okay, well, let's talk about the domain restriction first. If you recall from a previous math course, we can't divide by 0, and we have what's called a non-permissible value, or a restriction on x, with the denominator here. That there tells us x minus 2 can't equal 0, and if we solve for x, add 2 to both sides, we get that x cannot equal 2. Okay, so that would be our domain restriction. That's what they're referring to. Basically, if you let the denominator equal to 0, you figure out what value of x would not be possible. Now, let's go back to what they're talking about with simplifying. Okay, do you see anything that we could do here to simplify that? Notice the numerator has an x squared plus an x minus 6. We may be able to factor that. Okay, so a couple sets of brackets. X times x gives us x squared. We're looking for two numbers that multiply to negative 6 and add to positive 1, or in this case have a difference of positive 1. So 3 times 2 multiplies to 6 and has a difference of 1. Now we just have to get the larger number to be positive so that we end up with positive 1. So that means positive here, negative there. Okay, denominator x minus 2 still. And now that we have a common factor, we can divide that out. And the simplified expression would be x plus 3. Okay, now if you remember, x plus 3, y equals x plus 3, is a straight line with a slope of 1 and a y-intercept of 3. Does our graph look like that? Let's check it out. Okay, look at that. Y-intercept of 3 and a slope of 1. Up 1 over 1, up 1 over 1. Okay, well that's interesting. And where that x minus 2 in the denominator is showing up is this, with this restriction. If you put that in the graphing calculator, you don't see that hole in the graph. You'd have to go to the table to see that. And that only works if it's a nice integer. Okay, let's go to the next page. So this hole in the graph that I've been referring to is mathematically referred to as a point of discontinuity. And we're going to look at this in more detail when we do the rational functions unit. Okay, now in this investigation, the quotient of a quadratic function and a linear function simplifies to a linear function. We got x plus 3, y equals x plus 3, and then with a domain restriction of x can't equal 2. But that's not always the case. In many examples, the quotient of two functions cannot be reduced to a simpler form, and then we get definitely a different looking graph. Okay, let's look at example 1. In each case, write and simplify, where possible, an expression for f divided by g of x. Okay, so again, that notation simply means f of x divided by g of x. It's the same. Okay, include any domain restrictions. So we have to look at x values for dividing by 0. Okay, so we have f of x equals 2x plus 5, g of x equals x plus 5, so f of x divided by g of x would equal 2x plus 5 divided by x plus 5. Okay, simplify. Well, I don't see any x squared, so we can't factor a trinomial. There's no greatest common factor amongst the numerator or the denominator terms. You cannot cancel off those 5's, and the reason why is because 5 is not a common factor on top. It's not being multiplied by the 2x, nor is the 5 on the bottom being multiplied by the x, so you cannot divide that. Okay, so I guess what? We have no simplifying to do here, so we're off to the domain restrictions. Let your denominator equal 0, or say cannot equal 0, and then solve for x. So therefore x cannot equal negative 5. Okay, let's look at b. Actually, why don't you guys try b? It looks like f of x is a quadratic this time, so you may have to factor that to simplify it further. Okay, pause your video, and then we'll see if we have the same answer after that. Okay, so we wrote it as a quotient, so f of x on top, g of x in the denominator, and then you probably noticed the factoring, and I pointed that out. So we factor the numerator. Two numbers that multiply to 35 have a difference of 2 because of the minus sign in front of the 35. It's a difference. And that would be 7 times 5 gives you 35. We want the bigger number to be negative to end up with negative 2. And there we go. Not a coincidence that it canceled with the factor in the denominator, x minus 7, x minus 7. And our simplified form would be x plus 5. To find the domain restrictions, you set the denominator equal to 0 because you can't divide by 0. Solve that, add 7 to the other side, and we have x cannot equal 7 for our domain restrictions. Okay, let's try C. Again, pause the video and we'll see if we have the same answer. Okay, this one was a little bit trickier. Not with the factoring part. So we have f of x, x minus 2, over g of x, x squared minus 5x plus 6. We factor the denominator. Again, we have the same factors in the numerator, x minus 2 and then x minus 3. Okay, now before you cancel off, you need to look at what your domain restrictions are. So x can't equal 2, or otherwise we'd be dividing by 0, and x can't equal 3. Okay, so those are our domain restrictions right there. Okay, and then we divide that common factor. Now, x minus 2 divided by x minus 2 is 1, and you need to put a 1 there because you're going to probably think afterwards that your answer is just x minus 3, not 1 over x minus 3 otherwise. Now, why is that equal to 1? Think 5 divided by 5. What's that equal to, right? So when you divide the same factor, you get 1. And so therefore, this would be our simplified form of that quotient. Okay, let's look at example 2. Consider the functions f of x, 2x squared minus 13x minus 7, and g of x equals 2x plus 1. State the domains of f and g. Okay, so for domain, we could graph it and take a look at those graphs. This one is probably going to be a parabola, given that we have x squared, and it's a parabola that opens up because it's a 2, positive 2 in front. So that one in general, I don't know where the vertex is, but in general it would look something like that. In fact, let's not write the axes. So domain for that one, for f, is going to be x is an element of the reals. And we'll do that in set notation. So x, such that x is an element of the reals. Okay. This one, if you recognize the degree is 1, it's a linear function. So therefore, and it has a slope of 2, so it's going to look something like this. Okay. Again, domain, it goes forever left, forever right. So for g, our domain is going to be, again, x such that x is now in the reals. So for both graphs, x can be any real number. Part B, write an expression in simplest form for f divided by g of x. Okay, so again, f of x divided by g of x, we write it in that other notation, so it's a little simpler to replace or substitute. Okay, f of x, 2x squared minus 13x minus 7, divided by g of x, which is 2x plus 1. Okay, and they want simplest form, so we probably will need to factor this, and also state the domain, which means we need to look at the domain restrictions. Okay, and we might as well do that now because our denominator is fully factored already. So let's go ahead and look at the domain restrictions there. 2x plus 1 cannot equal 0. Solve for x, so we subtract 1 from both sides, and then we divide both sides by 2 to isolate x, and we have that x cannot equal negative 1/2. So let's just throw our domain in there now. It would be x such that x is an element of the reals, but, so comma, x cannot equal negative 1/2. So it can be any other number but negative 1/2. Okay, so let's see if we can factor that numerator. Okay, now whichever way you're comfortable factoring these, stick with it. And if you need some help on that, check out the factoring video. But your factors should end up being 2x, and we'll have the 7 here, and a 1 there. 1 times 7 gives you 7, negative, positive, and that should be your factors. Again, this factor should be the same if this is going to simplify. So that will divide, and our final answer would be x minus 7. All right. Explain 2 different ways to evaluate f over g at 3. Calculate that. We'll leave that to the next video, and we will see you there with that.